Hello.
Hello. Good evening,
Yeah,
sir.
good evening.
Good evening, everyone. Today we reached at the second day of the FDP, Sustainable Manufacturing and Advanced Automation in Industries. It is my great pleasure to welcome you all to this enlightening session. So it is with today we have the privilege of learning from a highly accomplished professional whose expertise in chemical engineering and process optimization has been instrumental in shaping industrial advancements. Please join me in welcoming Mr. BALAKRUSHNA SAHU, Deputy General Manager, Process at L&T Hydrocarbon Engineering Limited. With an impressive 18 years of experience, Mr. Sahu has played a vital role in the field of process engineering, simulation, and optimization, driving efficiency and innovation in hydrocarbon engineering. Mr. Sahu holds a bachelor's degree in chemical engineering from Indira Gandhi Institute of Technology and furthered his expertise with a master's in chemical engineering from the Indian Institute of Technology, IIT Guwahati. Also earned a project management certificate from the Project Management Certification Institute, adding to his extensive technical and managerial acumen. An article researchers, Mr. Sahu has contributed to the academic and professional community with 7 publications accumulating 42 citations. His involvement with the Institution of Chemical Engineers has further enriched with knowledge and expertise in the field. Throughout his career, he has specialized in the process design, modeling, and simulation, leveraging tools like Aspen HYSYS to optimize industrial processes. His work has significantly contributed to enhancing operational efficiency and sustainability in hydrocarbon engineering. So we are really honored to have him today to share his insights and expertise. Without further ado, please join me in welcoming Mr. BALAKRUSHNA SAHU. Sir, welcome to the session.
Yeah, thank you. 1 minute. Let me
Yes.
share the entire. If the problem is that if I share the entire screen, I will not be visible for any questions. So, but it is okay. Yeah. Now let me.
So, sir, at the end, the participants will ask the questions. So,
Okay. Is my screen visible?
yes, sir. Yes, sir.
Okay. So, as explained by Dr. Supriya, I was a alumnus of IGIT Sarang from 2006 batch, and after that I had done completed my masters in petroleum engineering from IIT Guwahati in 2008, and since then I'm working with Larsen and Toubro in various capacities from 2008. Currently, I am working in the offshore design and engineering team. So basically, this presentation is related to oil and gas processing overview. So mainly oil and gas. What is the oil and gas industry, and particularly we are working in the offshore industry. Sorry, hello.
Sir, sorry to interrupt, sir. You can make it this full screen, sir.
Yeah, I have done full screen. It's not visible.
Yes, sir. It is visible, but it is not the full screen, sir. So there, just click on the F5 button or the slideshow.
Yeah, I have
The
done
slide.
I have done the slideshow. It's not visible.
Yes, sir. It's visible, but it is not the full screen, sir. You can make it full screen now.
No, let me change the share the complete entire screen. Maybe that is the reason.
Okay, sir.
Is it visible now? No.
No, sir.
Some issue because
Yes, sir. Yes, sir.
I am clicking the slideshow.
Yes, sir.
Visible now? Hello.
Yes, sir. Yes, sir. It's good. Yes, sir. Now it's full screen, sir. You can
Okay.
proceed, sir. Yes, sir.
So before going to the presentation, I will just tell the where L&T Energy Hydrocarbon they work in the various aspect. So I work in the offshore division. So apart from offshore, we have onshore. Offshore normally deal with making all the facilities inside the sea. This is basically in the waters where oil and gas is extracted from the sea, and whatever possible processing done in the platforms located in the sea, and then transported to the onshore via pipelines. So we have another division called onshore, where onshore processing, after that it goes to refineries. So refineries and petrochemicals. Uh, then construction services. We have like a division called construction services, where directly we construct from other they cater the services for both onshore and other divisions. Then we have a value engineering department. They're called Advanced Value Engineering and Technology. Recently, we opened another division called Offshore Wind Farm to have the wind energy. Then we have also operation department. They got orders in various companies, and they operate the plants. That is called asset management. And we have our three yards. One at Hajira, another at Chennai, near Chennai, Katupalli, and third is at Oman. So there are three yards available at L&T. Now, yeah. So we'll start to the topic. So what is oil and gas? So oil and gas, naturally, it is a fossil fuel. So whenever there is a decomposition of marine life or the fossils, so they are settled in the seabed. Then over the time they are buried under sediment and rock. Then when there is a pressure and inside the below the rock, there is a increase in the pressure and temperature. So due to that, the organic materials are breaking down, and in that process, they form hydrocarbon. That we call it hydrocarbon. That is nothing but your crude oil and gas. So broadly, oil and gas is having three sectors. One is upstream. Upstream is nothing but that exploration. It is either onshore or offshore, where then the production is happening. 1 minute. Uh, so the production is happening. Like offshore means it is inside the sea. Onshore means like wherever Assam and some other places like in India where it is produced in the drilling. So drilling part and a little bit processing in the upstream sector. Then it is transported to the refineries where it is the midstream. Midstream means like you can call that okay. There is a fine line between mid and downstream. Downstream, basically, we can broadly tell that it is the chemicals. The chemicals we produce from the petroleum, and midstream maybe we can call that petrol, diesel, and kerosene. All this the extraction. So this is the broadly categories. And what I am working in the offshore oil and gas is oil and gas is related to upstream. Okay. So in the upstream oil and gas life cycle, there are 6 phases. First, there is a licensing. Licensing is done by every year. There is a NELP and DGH, Director General Hydrocarbon. So they will license they will give the contract for the fields. Different bidders will bid. Like currently in India, ONGC is the largest ENP player. Apart from that, we have Reliance, and slowly Adani also entered, and Sun Petro. So many small companies are also now entering into this area. Then there is a exploration. Once you got the field, you find search for the oil and gas, where the possibility of the oil and gas deposit, and you try to locate based on the reservoir study. So that phase is called exploration. Then appraisal. Appraisal means based on the testing, you know how much gas and oil volume is there, and how much time it will take to produce, like what is the life cycle. So minimum life cycle, whatever projects what we are doing is a 25-year life cycle. So at least 10 to 15-year life cycle should be there. Otherwise, there is no point in investing huge amount of money. It will not recover. So after that, there is a next stage is development. Development is to build the surface and subsurface facilities, so that all the platforms and the process plants we are building, that is called a development. Once that is commissioned, then called production. Then after drilling, actual fluid is coming. Then you export to different, like suppose let's say now ONGC is producing gas, so they are selling that gas to GAIL, and GAIL is distributing to across the India everywhere. So that is called production. Then abandonment means once your life cycle of the well is completed, around 20 to 25 years, so you have to close the shut in the well, and you have to do abandonment. What is happening? Light. Yeah. So offshore oil and gas facilities, like we call it as a platform, like plants is known as platform. So we have a wellhead platform, where the wellhead platform will look something like this. One platform will house around 10 to 20 wells, like minimum is around 8, maximum is around 20. So there will be 20 wells, the risers, like the production, after production it will come. So this is a like collection from the well. So this is a wellhead platform. Wellhead platform, there will not be any processing facilities. So only minimum facilities will be there, like Christmas tree and other, to gather that, and they will put a pipeline and to transport to the nearest process platform, or in some cases riser platform. Okay. So these wellhead platforms based on the production, like some platforms are oil platforms, some are gas platforms, some are like water injection platform. Whenever there is a pressure is less in the reservoir, then few of these wellheads, they will inject the water to increase the pressure, so that other wells will produce more. So like this wellhead. Then next is riser. Riser platform is like it is a kind of coming many lines will come from different wellheads, and they will combine in the riser platform. So riser platform concept is there in the Middle East, but in India there are no riser platforms. All lines like different. There are 10 wellheads, so 10 lines will come to a one processing complex. So that is called as process platform. So process platform will have because there is a processing complex, there is a human intervention is required, operators are required. So there will be a living quarter platform. So in this drawing, the bridge connected is a living quarter, where actually people will live. Normally around 100 to 150 people will live in this platform, and they will work in the shifts in this processing complex. So this is called living quarters. Water injection, as I explained, whenever there is a drop in pressure, reservoir pressure, and production declines, then some of the wellhead platform will be converted to water injection, and high pressurized water is injected in the reservoir to increase the pressure, so that the oil being lighter will come to the up, and it will flow due to pressure. Okay. So yeah. So apart from this, there is something called floating production, storage, and offloading (FPSO). All these platforms concept is applicable only in the shallow waters. When there is a deep water, 2 to 3 kilometer depth, water depth is there, then you cannot create a platform with this kind of legs in that much depth. So in that case, it is a kind of ship. Once ship is converted into a platform and that will float. So that is called floating platform. So as explained here, so there are different types of, so first I was talking about that fixed platform where there is a certain depth and we convert we call this as a jacket. So this jacket can be as small as like tripods, like 3 legs to 10 legs. Bigger jackets are up to 10 legs. So after that, and this is the last, this is the floating. If the deepest, so you cannot do anything. You have to convert a ship and house the process facility there, and the well will be much below, and through there it will come this like high tension lines. So the floating lines, the lines will be floated and buoys will be connected. So in the wellhead, the main facilities are available as a Christmas tree. Christmas tree will be looking like this, where it is a combination of multiple walls. So uh, the role of Christmas tree after this, like it will have a surface safety wall, it will have a subsurface safety wall, and downstream of this, it will have a choke wall. So the surface safety wall will be located above the water, and subsurface safety wall is located on the seabed. So basically, if there is an emergency, these two are these emergency walls, which will be located one at the surface level, one at the bottom level. So this picture is at this is the onshore, but what I explained is offshore. Surface safety level means it will be located in the platform, and subsurface is at the seabed. And choke wall is downstream of this Christmas tree, which will control the flow. Let's say reservoir pressure is 500 bar, where we require to produce only in 20 bar. So the pressure reduction is happening in the choke wall. Okay. So this will look like in PNID, like if it is a wellhead platform will have a SCV, means this is a choke wall, and there is a MOV, this motor operated wall. So like if there are 10 wells, so 10 lines, producer line will come and they will form a production manifold, and the manifold, that line will again go to the down and form a bigger pipeline and will transport to the nearest line platform or process platform. So there also we have a testing facility called either multi-phase flow meter or test manifold to actually test how much one well is producing, to know whether the each well health, like whether some well is saturated or some well is producing and not producing, that can be known. So once it comes to tie-in platform or process platform, so after processing, like process platform means what? This crude is basically oil plus water plus gas. So process platform segregates the oil and they pump back to the onshore through a different pipeline. And the gas, and they have a gas processing, like some units like gas dehydration, gas compression, and pressurize and transport to different pipeline. Water they will process so that they will not be harmful to the sea environment, and once this is processed, they will dump inside this sea only. So this is the work of this process platform. So this basically this processing first equipment is called separators. So separator is a vessel. They primarily there are two types of separators, either two-phase or three-phase. Two-phase means liquid and gas, and three-phase means oil, water, gas separation. Yeah. So either we can give vertical or horizontal, and with different like this is a production separators, or sometimes when we are doing flaring and or flashing the vessel, so that application also we can use like flare KOD, and similarly in the compressor suction we call it a scrubber. So these are also kind of separators. So what is the principles of separation? So separators work in various principles. Like if it is a momentum, like momentum means there are two different density fluids are there. So the lighter will turn faster, then heavier will turn slower. So by the momentum separation, you can separate the two phases, or you can separate like gravity. Like you're given a residence time, and suppose this is a separator, you are flowing a fluid. Inlet is here and outlet is this side. So by coming from here to here by gravity, like some water, suppose oil and water is there, water being heavier, water will settle down in the bottom side. So the droplet by means of gravity separation. Sometimes there is gravity separation is not feasible when there is the densities of the liquids are, if it is very nearby, then we can use centrifugal force, or we can use filtration if there are solid also available. So this is typically a conventional gravity separators, where this is the inlet line. Then there is a deflector plate is there to change the momentum. Then there are coalescing plates are there. Coalescing plates means they will like once disperse different particles are like gas particle, oil particle, and water particle. They are dispersed. So they will coalesce. Coalesce means make it bigger. Similar kind of particles will combine. Then after that, the outlet line, they have a mixed elementer. Once the gas is going, because gas will rise because of low density, so gas will rise to the top. Anything liquid is carrying over with the gas, they will trap in this mixed eliminator and come back to the system. So this item is called as a wear. So left side of the wear, because of gravity, this water is settled in the bottom and oil is settled in the top. So wear is designed such that it always overflows. So only oil is going to this chamber. So this chamber outlet I will get oil, this chamber outlet I will get water, and top outlet will get the gas. So that's how we separate oil and gas in these separators in the process platform. So once it is separation, then the gas will have the saturated water content. So if you do not remove that water while transporting to onshore, after few years they will start corroding because of that water. They will form the corrosion. So it is necessary to remove that water content which is saturated by gas dehydration. And if the pressure is not sufficient, pressure from the well is not sufficient, you require high pressure at the onshore and you have to transport many kilometers of pipeline, then accordingly you calculate what is the pressure requirement, and we have to provide a gas compression system like compressors. So the once it comes to onshore, like it will be sent to users like GAIL and other some places, or maybe wherever you want, like any petrochemical plant, or you want to LNG application, we can send. Similarly, oil after little bit processing, oil will be pumped to the refineries to further make it the petrol, diesel, lube oil, bitumen, etc. And the water after treatment, and it is fit for not fit for the purpose. Once we receive the specification, then we can dispose in the sea. That is called produced water treatment. So apart from this, we have also a system called gas sweetening. If the gas is having H2S or CO2, then it will become very highly corrosive. If H2S and CO2 is there along with the water, they will form very highly corrosive. So we need to remove the H2S, which can be removed by a package called gas sweetening system. Normally, this is a typical flow where there is a amine absorber or contactor is there, and the fluid is going from the bottom and solvent will come from the top. So they use the solvent as either diethylamine or methyl diethanolamine. So the popular is MDEA, which is used in the industry. So once it is absorbed, so that liquid solvent will absorb the H2S and CO2. So then that liquid become acidic. Then that same thing is going and filtered, then flashed, and regenerated in the system, regenerator. So in the regenerator, what they will do, it is heated by a reboiler so that whatever H2S and CO2 it is absorbed, now they will dissolve. That H2S and CO2 it will go to the from the liquid stream, it will come out and they will flare it. Flare it means this H2S they will burn in the flare, so it will form like SO2. So it, of course, it will create SOx and NOx, but within the permissible limit on. And if it is very high, then they can be further sent to a sulfur recovery unit to recover the sulfur. So this is the way the H2S and CO2 is removed from the gas. So now this is called sweet gas because this if H2S and CO2 is there, they are called sour gas. So after the removal of the sour component, it is called sweet gas, and then that can be sent to further water removal in the dehydration and compression systems. So these are the different methods like adsorption, commission, and absorption. So the preferable in this offshore industry is absorption technologies. Also, some places they use adsorption, but adsorption molecular sieves they use it, but that will be need to be frequently replaced after some periodical times. This molecular sieves. And second is the gas dehydration system. So gas dehydration is in India, the normal pipeline specification is 7 pound per SCF of the gas. This much water is allowed, and it has been seen that if you do not maintain this quality, then there is a increase in the corrosion rate. So this is the guideline, and few of the processes are available to reduce further below this. Okay, so to remove this, the solvent what we use, it will be similar like gas sweetening unit, but the solvent will be used as a triethylene glycol. We have also monoethylene glycol, diethylene glycol, but the highest efficiency shown by this solvent is TEG, and it is perform better at the higher operating pressure. So after GSU, normally people put a compressor, and once it is compressed, the compressed gas we send with the dehydration, and once it is dry, then it is sent to the pipeline. So this kind of a flow diagram where the gas goes from the bottom and glycol comes from the top, and this glycol will absorb the water in the packing while coming in the process. So this is called the absorption process. Once the glycol is absorbed, then the glycol called rich glycol. And the rich glycol means this is glycol plus water. So water content is very high. So then it will come to the regenerator. Regenerator is having a combination of reflux condenser, steel column, and reboiler. So basically we are heating here to remove the water vapor. But the process is not so simple. So if you heat at 200 degrees, many of the glycol will also go. So then there will be a huge glycol loss. Then that will increase your operational cost. So to remove that, to recover this glycol, we have this packings here. So that this is also a column, steel column. And to improve the efficiency, we have another column bottom side, stripping column. If we are not able to achieve 99.5%, so we can use a separate stripping gas like dry fuel gas, so that will strip further 1 or 2% water which cannot be separated by normal heating. That is heated by the that can be done by stripping. So this is the typical process of the gas dehydration. Okay. Next, gas compression. So gas compressor normally why it is required? If a required pressure is if you have to send to a multi-kilometer pipelines and your inlet pressure is less, or you have a customer you have to deliver at a very high pressure at the onshore when you don't have that much pressure, considering the pressure loss in the pipeline. So you have to provide a compressor at the offshore. So compressors can be reciprocating centrifugal rotary screw based on the applications, but typically centrifugal compressors are used when there is a high flow rate and high pressure applications are involved. So the compressor system will have like one KOD and one compressor. Compressor will be coupled with a gas turbine. It is a offshore, all are majority are driven by gas turbines because along with the oil, gas is producing. So same gas will be used to power the turbine, and turbine will run the compressor with the same shaft. Wherever there is a power available is there or gas is less, they can use motor driven also. But for that, the requirement is that power should be available at the platform. So this is like a single stage. So like this, based on the pressure requirement, we go for 2 stage or 3 stage. So like suction KOD, then there will be a compressor. Once you compress a gas, then your outlet temperature will increase. Then you have to again cool. So there is a cooler. So coolers basically we use as air coolers in India, and but Middle East the ambient temperature is very high. So Middle East we use the seawater coolers. So if you use seawater cooler, we have to give a seawater pumping system separately. So after that, it will go to the KOD. So this completes a 1 stage. So 1 stage will have around, if centrifugal compressor, maximum compression ratio 3. So let's say I have a 5 kg or 5 bar suction pressure, I can deliver around to 15. So if I need a 90, so 5 to 15, 15 to 45 or 45 to 90, I need a 3 stage. So that one equipment will come in that package. So compressor working principle, compressor is a total mechanical energy is associated with and gravitational potential energy and kinetic energy. All three remains constant. So that is the Bernoulli's principle. So if potential energy is kept constant, then if you reduce the kinetic energy, that will increase in the pressure energy. So I need a high pressure. So keeping the potential energy constant, you have to reduce the kinetic energy. That is the velocity. If you reduce, then pressure energy will be increasing because all three sum is constant. That is Bernoulli's principle. So like example here, so this is the flow path. It will come from the impeller, then diffuser, then go into the return channel. If you see, if fluid enter to the impeller, though then it will go to the periphery by guide blades. So in this, the velocity impeller is going to impart it to the fluid. So kinetic energy increase. So first step, kinetic energy increase. Second step called diffuser, where the velocity is decreased. Then reduction of the kinetic energy. So this is the diffuser. You see, this is the diffuser. This is the second stage. First stage is like this. So this is a simple concept like compressor. Even though it is like most critical equipment, it works on same principle, like fundamentals of Bernoulli's principle. So this is a thumb rule we follow normally the compressor selection guidelines. Whenever there is a higher pressure with a higher flow rate, we use a centrifugal compressor. But if you require a high the compression ratio, but low flow, then reciprocating is okay. And if the small flow rate is there, then you can use a liquid ring compressor or even screw compressor. Yeah, so that is about gas. Now oil. Oil, the most impurities of oil are like salt. Normally there are dissolved salts and like BSNW, base sediment and water. So the salt content cannot be removed directly by the separation. So for that we provide a desalter. Normally that is a kind of electrostatic desalter where you have to give the electric field, then it will polarize and coalesce the small droplets into the larger one, which will settle in the bottom, the gravity. So the salt content normally we reduce to 10 ppm. Why it is required? Because it is required to when you are producing some oil, there should be some quality requirements are there. So typically the quality requirements are that we have to maintain a reed vapor pressure, and because based on this quality, there are the costs are involved. If you are giving a lower quality product, then cost will be less. So that is based on customer requirements. So either you can use electrostatic desalter or sometime only crude stabilization column. Just you stabilize for some hours, then remove the lighters. Then we are having a butane, propane, and butane. So you want to see for normally butane plus is good enough. So the these two ways we do the oil processing. Then the third one is called water processing. Water processing, we use like hydrocyclones, the cyclonic movement. Then first is the hydrocyclone. Then secondary treatment is degassing. Degassing is by flotation method or IG induced flotation or dissolved flotation. Then tertiary maybe by additional filtration. So the separator, after separation from the water, from the separator, normal they will have around 1000 ppms of water, 1000 ppms of oil in the water. Hello. Yeah. But it is not safe for the marine environment to dispose that amount of oil inside the sea. So we provide this produced water system for this purpose. So first, if you give only de-oiling hydrocyclones, it can reduce up to 50 ppm. Wherever the acceptable in India now is you have to reduce up to 25 ppm before sending or disposing in the sea. So we have to provide additional unit called as degassing unit. Hello, hello. Can somebody mute? Yeah. And then a induced gas flotation system where what is happening? We induce the purge gas. Purge gas is nothing but a fuel gas. Then it will bubble. It will form the bubbles. Then that bubble will coalesce the oil droplet, and oil will come on the top, and they will skim off the oil from the water because the oil quantity is very less. So you are channelizing the oil by purging the gas. So this way we can reduce up to 20 ppm. If there is a sand is there, sometimes because it is production, the oil and gas production is happening from the seabed. So naturally the sands will come. So if the heavy sands are coming, then we have to give a desander like package where the sand slurry from the separator it will come, and the we have to give a separate clean water, and they will have a cyclonic action. So they will mix this slurry with the clean water and have a cyclonic action where the oil, little bit oil, whatever there, that they will recover from the top, and oil water slurry they will recover from the bottom, and they will dispose. So the next aspect is LNG, that is liquefied natural gas. So what is LNG and why it is important? So LNG is a natural gas that has been cooled and condensed into a liquid. So if it is condensed into a liquid, that means what pressure? The what is the temperature? The temperature is around -162. If you reduce the temperature to up to -162, then gas will become the liquid. So in this case, we can like this much natural gas for a pictorial representation, it can be reduced to this much volume. So it can be transported into the tankers. Like 1 meter cube of LNG is equivalent to 600 meter cube of the gas. So whenever there is a like country wise, like India is buying some gas from some of the countries, wherever there are pipelines exist, they buy from that through the pipeline route. Wherever pipeline doesn't exist, or some buying from Russia or any far places, the economical is to buy the LNG. So LNG normally they transported in the cargo ships, and we can get that LNG here, and we can regasify this liquid to if you bring the gases test, and we'll get a huge volume of the gas. So in LNG, like this exploration production, then onshore we do liquefy, and you this like put into the spherical vessels and the ship. Once it comes into the terminal, LNG terminal, then that's, that gas, that liquid is gasified in this regasification and transported through pipelines throughout the consumers. These are the various technologies available for LNG liquefaction. Yeah, and just I have taken few pictures like how very large, like gigantic heat exchangers are used in the LNG, like spiral wound heat exchangers. If you see that the tube bundles, there are thousands of tube bundles are used and crisscross. They wrap one above another to get the better surface area within a compact space. So this kind of technologies are being used in the LNG. Then the last aspect of this oil and gas processing is chemical injection. So every wellheads platform or this process platform, we have a chemical injection system. Chemical injection is normally even though we taken care the water content and everything, there are some offset cases where there might be chances of corrosion, and to prevent that, like oil stream, there is oil corrosion inhibitors, OCI we call. Then gas stream is GCI. So like this, different chemical are there. So they will be stored based on the requirement lab analysis. We know how much to inject. Then there will be a system where dosing pumps are there. They will dose into the pipeline. Okay. So there are different chemical, these kind of chemicals are injected like corrosion inhibitor to prevent the corrosion, GCI and OCI. Scale inhibitor, sometimes there are scales are being formed in the pipeline, so scale inhibitors are being injected. Then if there is a emulsion, oil water emulsion is there, then we need to break that emulsion. Otherwise, the separation is not feasible in the production separator. So before the production separator, you have to put the emulsion breakers. Then if there is a micro growth is there, we have to provide biocides. And similarly, if there is a hydrate inhibition, hydrate formation means there is a, like if there is a water content is there and it enters to the hydrate, it will form ice and choke the pipelines. To prevent that, if you cannot control the process parameters, like you cannot control the pressure reduction or you cannot control the temperature reduction, the only way is to prevent, you have to inject this chemical in the upstream before the pressure reduction, so that even though you reduce the pressure and the temperature is going below to the hydrate formation, it will not form hydrate because you are altering its molecule. Uh, So there are the utilities. So apart from this, there are some utilities available. Like as I told, the living water, the people will be staying in the offshore. So you have to have a potable water system where you have to have a potable water maker, then pump, then everything will be there, because there will be rooms, there will be kitchen, there are toilets everywhere. So you require potable water, like you require hot water for the galley and the showers. Like fire water, definitely it is required because it is a offshore system. If there is any fire, automatic sprinklers, it has to be fire compliance, so that automatic sprinklers are available throughout the platform, along and apart from this, along with the living water also. And apart from that, there are fire hose reel stations there where operators can use to do the firefighting. And similarly, the other utilities like instrument or utility air, because all valves we are using is actuated valves, automatic on-off control, so that require air as a medium. And whenever there is a power, there is no power in the platform, like some system upset and everything become trip and plant shut down, then we have emergency diesel generator where using diesel you get the power and make the system ready and restart. Then jet fuel is like every platform will have a helicopter, helipad for people to come and going. So the helicopter once landed, so some places they have to refill the fuel. So we have to have a jet fuel system. So these are the other systems like power generation and flare and drain. I explained. Then whenever seawater is required for fire water and other purpose, we have a seawater system. And if persons are staying and toilets are there, then we have to use a sewage treatment plant. So these are the various systems are available utilities. So that's it. This is the total overview of a processing complex.
Thank you, sir, for this interesting
Yeah.
and informative session. Now the participants can interact with the speaker.
Yeah, if you, I have another 2, 3 slides. If anybody has not questioned, then I can share that also. Just wait 1 minute.
Yes, sir. Yes, sir.
Screen is visible.
Yes, sir. It is
Yes, sir.
visible.
Yes, sir.
So this is the typical block flow diagram of the process flow. This is what we call like these are the wells, different wellheads. Like this is not well, this is a wellhead platform. So there are 20, 15 or 20 wellhead platform. So 20 lines are coming into the process platform where in this particular case there was a wax is there. So we need to heat that well fluid. So we were heating the well fluid. Then it was going to the first stage separator. The arrow it is moving is that is the oil stream. So once the separator oil is separated, then that oil was going to the LP separator because all gas cannot be separated in one stage. So after we are reducing we are getting this oil from the HP separator, we are little bit heating it, and so that there will be some condensate like some gases are forming, so that we are sending out. And this oil we're sending a third stage like what I explained, that we need to stabilize to meet the customer requirements, what is the product quality requirement. Once it is stabilized, so it was sending through the pump. There were two mode of pumps are there, like main oil pump that was sending through the main oil pump was sending through the pipelines. Wherever the CT pumps are there, whenever there is a tanker is there, sometime directly this project was for ONGC when they directly sell. So some ships are coming to directly offshore. So there is another provision that crude CT pumps. So there were no, two systems. So once this is oil system is there, then now gas. So the HP separator, what are the gas separated from other platforms? Some gases are coming. So these two, and the very low pressure gas where it is going, that is again compressed at the LP screw compressor. So all three combined. So all three combined, they are sending into the process gas compressor. So this process gas compressor, this was like this particular project was around 5 bar pressure at the suction. So we have to increase to 96 bar. So this process gas compressor is we are having 3 trains. and 3 stages. So 5 bar to 96 bar. After increasing the pressure, then we were having a 3 dehydration units where we use the triethylene glycol and remove the saturated water content. Then after that, there is a gas metering station. Then we meter the gas and how much gas is produced. Then that is being exported to the onshore. So while doing this, few of the field, like there is a called B series field. One field they were coming highly sour gas. So there was a for particular that field there was a gas sweetening unit was there. So gas sweetening, what is the sweetened gas is that was mixed with this sweet gas. Okay. So then whatever condensate is there, then the condensate is being spiked down into the and re-injected in the gas. Similarly, the waters from HP separator, LP separator, stabilization vessel, and condensate handling all are treated in the produced water system, and they sent to the sumcation. Sumcation is the final means of disposal into the sea. So this is located in the jacket level and bottommost level of this platform, where the treated water is disposed is having a specification requirement of 25 ppm of oil in water. So that were the processing systems of a typical process platform. These are the utilities. Utility means we have a fuel gas field. Fuel gas is a utility. So there were around 1, 2, 3, 4, 5 fuel gas field. The one P is for primary, and others are secondary. For each compressor unit, there is a dedicated fuel gas field. Then we had a hot oil system, because hot oil system is used to recover heat recovery. Like it was kind of green initiatives when the turbines run, the high temperature flue gases will be emitted into the environment around 500 degrees Celsius. So if there is a heat requirement anywhere, you can recover that heat from 500 to you can reduce that to 200 or 250. So balance heat you can recover, like, so that we had given a system of hot oil. So hot oil, how we are recovering that hot oil will send through that system and take that heat from this flue gas, and the hot oil temperature will increase to 260 degrees Celsius. So that heated hot oil we are using in this regenerators, where I told around 200 degree we are maintaining in the GDU and GSU places to regenerate the liquids, so that to strip off this water content and H2S, CO2, whatever they have absorbed. So that heat is nothing but we recovered that heat from the turbine outlet using the hot oil system. So this is the hot oil circuit. And chemical injection, like that platform we have GCI, OCI means oil corrosion inhibitor and gas corrosion inhibitor. We have a demulsifier, because the emulsion was forming, so separator will not perform if there is emulsion. So to have to break the emulsion, we have to inject the demulsifier in the production header before entering into the separator. And as we are having one stream is having high H2S, so for that we had a dedicated acid flare header. Flare means nothing but there is a burners are there and continuously it is running. And it will run through a pilot gas. So pilot gas is nothing but your fuel gas. So fuel gas is continuously supplied with a very low quantity and it will burn. So whenever there is a release from the process system, because the burner is on, so it will be able to burn all the gases. So the gases will not be emitted into the environment as without burning. So unburned gases, cold venting is not permitted. So that is the regulation requirements. Next. Yeah. So apart from that, yeah, then there is a LQ was there, 150 man living quarter was there. So in the living water, like I told, we have crane, we have emergency diesel system. So we have to have a diesel storage. So there is a diesel storage system was there where diesel was used in the deck cranes. Also for operation of fire water pump and emergency diesel generation purpose. Uh, similarly the water maker, because persons were available, 150 persons were staying, so they need the drinking water, potable water. So the RO based, normally we give two types, vapor compression type or reverse osmosis type water maker. So they will use the sea water, then sea water to make the potable water. So that is for drinking purpose. And the wall actuation, we convert, take the air from atmospheric air, and they convert into the utility air. Then with the air compressor, we'll compress. Then we put a dryer and reduce the temperature, the dew point up to -40, so that the all the moisture is removed from the instrument air, for the air, and that air is called instrument air, which is being supplied into all the instruments. Also, it will be given as an input to this nitrogen generator, where using this instrument air, they will uh, prepare a 99% pure nitrogen. So that nitrogen will be used for purging and blanketing purpose. Whenever there is a maintenance is there and some person has to enter into the vessel, so to remove this highly toxic hydrocarbons, we have to purge it. We have to stop the production and depressurize. Then we have to pass through this nitrogen. On sometimes some vessels they require little bit low pressure blanketing. So this was this facility available in the LQ, and there was a STP, sewage treatment plant. The toilet salt wastage was going to the STP. So that's it.
So participants, you can now interact with the speaker. If anyone have questions, please ask.
Yeah, there was one question: is LNG is environmental friendly? Yes, LNG is very clean. LNG is nothing but your mainly methane, because they will remove, see, like before processing the LNG, they will remove the liquids. Like they will remove the debutanizer, they'll remove the butane. Then depropanizer, they'll remove the propane. Deethanizer, they will remove the ethane. So basically, it is a measure of methane. Methane is very light, and so methane, we see anything you burn, you will get CO2. So if CO2 is a concern, that can be separately addressed, like today's what new technologies, like they capture this CO2 and re-inject into the system. That can be done, but LNG is far better than the normal gas. It's very environmental friendly. How can we reduce carbon emissions in LPG extraction and refining? See, any places like yeah, I have given this presentation for offshore, but in LPG also in refining, there is something called reformers and reforming equation. Then normally people do this. Then this CO2 CO2 they will convert into that urea, ammonia, and then ammonia plus CO2, then the NH2 CO NH2. So in every places, if you see the refinery, they their byproduct, they will create a byproduct, like they can convert this CO2 into many ways, and they can reduce. And the government is giving incentives if you getting carbon credit, so that's not a issue. It's being followed now. Plastic, plastic is a byproduct of petroleum. No, directly we cannot say, but yes, chemicals. So if you say polyester is coming from polystyrene. Polystyrene is monomer is styrene. Yes, styrene can be produced from uh, this gas. So gas, you like I told, the downstream industry is nothing but all chemicals. All chemicals is produced from this uh, naphtha. No. So after midstream, once your petrol, diesel, and kerosene, everything is produced, balance whatever remain, that they will process and manufacture many chemicals. Then, can we phase out fossil fuels by 2070? Maybe, but we have a huge reserve of oil and gas. I don't see at least another 40, 50 year. I don't think they maybe this EV and the green hydrogen, mainly green ammonia, people are now targeting, can be a part of steam, but as long as that is successfully implemented in a low cost manner, if their production cost is less than what is oil and gas, till that time we cannot replace, because it's all about money. And if your economy is booming and you require energy and you require from fossil fuel at a lower cost, let's say 20% lower cost, then government will not invest. Yeah, government now people are investing, so that slowly we know whether it can like, once you enter into that field, then only you invent new technologies and make it more feasible and more cost effectiveness. So maybe it might be possible by 2070, but we have abundant hydrocarbon reserves available.
Good evening, sir.
Yeah. Good evening.
It's my very small question to you. What are the most energy efficient technology for LPG processing?
LPG processing, yeah, because I work in the upstream sector, as I informed, no, I work in the upstream. So I don't have any experience in the mid and downstream. LPG comes in the mid stream, when there is a refinery, liquefied petroleum gas. No?
Yes.
So you can ask anything related to the upstream, because my entire career I am in the upstream only.
Participants, any other questions you can ask? Okay, thank you, sir, for this informative session. And participants will join for the next session at 7:30.
Okay, thank you. Thank you very much
Sir.
for providing the opportunity.
Thank you, sir. Thank you, sir.
Thank you. Bye.